Hello, welcome to Lesson 3. The featured topics are geometric constructions, scales, center lines, centering, multi-view drawings. These are important topics in our early stages of developing drawings. The first thing I want to do is show us some geometric constructions. And as you can see on the list of topics, there's associated pages in the book, page 138 to 156. Why geometric construction? Well, again, they are small pieces of drawing elements that can go into larger, more complex shapes. And this will also help us in our early stages to become more comfortable with the equipment and techniques. So a lot of this is technique driven. What I'm going to do is demonstrate 4 geometric constructions, and again, there's many, many more, and I want you to follow along with me. So hopefully on the Moodle, you've downloaded all of the course material, printed it out, and you're ready to go. Okay, so I'm going to take us over to the direction table, and we will start developing some geometric constructions. Okay, so I'm going to take down a drawing, and actually I'm going to use paper that's like our college drafting paper. It just doesn't have a title block on it. All right, so we're going to create 4 geometric constructions, getting us more comfortable with our equipment. Now, when you create a geometric construction, the name of the first one that we're going to do is what's called bisecting a line. Okay, so it's basically problem solving, and our problem is we need to bisect a line. These typically have something to start out with, which we'll call givens. You don't just walk up and the paper's empty or there's nothing to start with. So in our case, for this first one, the given is going to be line AB. And what I want you to do, and it doesn't have to be perfectly horizontal, you can just use the straight edge of your triangle and just come down below that a little bit and draw me a line. I'm even going to draw it crooked to show you that it doesn't, the length and orientation of that is of no bearing to solving the problem. Okay, so that's what we're starting out with, and let's label this as AB. So we need to bisect line AB, and I want you to ask yourself, do you even know what that means? What does bisecting a line mean? Well, bisect means cut in half. And what we're going to do is find the halfway point of line AB. I want to show you in the textbook, starting on page 138, that we have multiple ways of bisecting. Okay, so if you follow the progress of this, you'll see across the top here, let's say step 1 is here's your line. Step 2 is you're going to strike a radius off of each endpoint, and then you're going to connect the intersections of those 2 arcs with a line which will then have bisected. You can also bisect an arc, and on the top of the next page you can bisect an angle. Okay, it shows you steps A, B, and C. Alright, so that's what we're going to do on this line. So we're going to need our compasses. And let's use our smaller compass since we haven't used this yet. Remember what I told us last class, the point has to be set up for this to effectively work, where the extreme steel point, the lead has to be out half of that. Okay? So I don't know how clear that might look, but the lead should be halfway out that extreme little sharp point of the steel tip. If it's not, you need to adjust it. And then remember, you're going to tighten both of these wheels as hard as you can. You don't want that slipping up into the table. That's going to set you back and you have to readjust it. All right, with that said, I'm going to open up my compass, and to how much? Well, we're not going to have an actual amount here, but in the end of things, you're looking for the halfway point. So to do this properly, you just need to open your compass up so that it is more than halfway. All right, so I'm just going to open that up a little bit so you can watch me do that. And I am certainly more than halfway across that line. And I'm going to strike an arc above and below that line. And in the vicinity of where the halfway point is. So from the end point of A, I'll put a little notch just to emphasize that. So right at the end point of A, I open my compass up to be about a little more than halfway, strike an arc above and below, and then I flip my compass around and put it on the end point of B. And I do the same thing. I'm going to be striking arcs through the first two. You want to find where those two intersections are. So now I have 4 arcs. Each pair intersects one another. And then I take my straight edge and I line it up with those intersections. And I draw a line right through that. Okay? And I will now have intersected line AB. You get one more thing out of this in that line is also perpendicular to AB. So that bisected line also forms a right angle to that, which can be helpful. So if you took the 90-degree corner in your triangle and you set that right in there, that should be a perfect 90. Okay, so you can draw that. All right, so that's our first construction. Get our equipment warmed up and our technique going. Let's jump to another one here. So this we'll call number 1. Number 2 here is going to be a very useful one for us for the rest of the semester. This is called an arc tangent to a right angle. Okay, an arc tangent to a right angle. Now, we're a little bit familiar with this. Last week, when we first started drawing techniques with our equipment, we did these 4 problems. And the 4th one we did, that is technically an arc tangent to a right angle. This line is horizontal, this line is vertical, and whenever you hear the word tangent, that means something blends perfectly into another. So if you did this right, this arc blends perfectly into that. But the way we did that was a little backwards, and that was fine for last week. But now I'm going to show you a more efficient way of doing that, because we're going to have to do this a lot, and we want to do it quickly and easily. So the way we're going to do this, our given, right, what are we starting out with here? We're starting out with a right angle already. And an arc of a known radius. Okay, so we start with a right angle, and we'll have an arc of a known radius. So how are we going to get our right angle? Well, you can take your triangle and set it down, and we're going to keep this towards the upper half of the paper because we're going to do 2 more in the lower half. And I'm just going to I'm going to trace over this angle to get a right angle. All right, so I need a nice 90-degree angle. I could use this first technique to get a right angle and go from there, but the other thing I want you to note is typically this would be very light. As I emphasized last week, when you start out your drawing, you want to always keep your 0.3 millimeter to do the layout. But for the sake of you guys seeing this, I'm drawing dark lines. But realistically, everything would be super light. All right, so there's my right angle. Now, with your compass, I'm not going to ask you to set this to an actual amount, which kind of goes against this arc of a known radius, but because we haven't formally learned scaling and gotten comfortable with our measurements yet. So what I want you to do, just as an easy thing, is open your compass up so that it's about halfway out of one of these sides. And it's really not critical whether it's a little bit more, a little less, so don't stress out. Just get it to be about halfway. All right, so I put my compass point on the corner of the right angle, and I strike a small arc on each side of this right angle. So you can see these little marks here, and again, they should be super light, but not a problem right now. So once I've drawn those two arc marks, now I'm going to take my compass and put the point right where that arc intersects with the right angle, and I'm going to strike another arc directly across from it. And I'm going to put my compass point on this bottom arc where it goes through the right angle. And I'm going to strike another arc going right through the previous arc. Now, I haven't readjusted my compass at all during any of that. Okay, so that's actually the center point of the arc I really want to draw. So now that I have that drawn, I'm going to put my compass point right in there, and then these first two marks become start and stop points for my arc. That's the point of tangency. So I'm going to start right here, and I'm going to draw that arc to go from one to the other. And I'm going to draw that back and forth a little bit to make that nice and dark, and build my line thickness up. Okay? So in reality, we would take our eraser shield and we would erase off the excess and wind up with that nice clean arc. And then we would go back with our pencils and darken that all up to our acceptable 0.9 millimeter thickness along with the arc. So that's always the follow-up of draw it light and then finish up with it being nice and dark. And you have to readjust your compass slightly to build out that thickness. Okay, so you're going to be doing that often, and whether that be larger or smaller, that's the technique. So remember, you start off at the right angle, adjust your compass to the required measurement, strike the two arcs from the corner, find the intersection of those two arcs, and then draw the real arc that you're looking for. All right. Let's do the third one. We're gonna take this number 2 construction and we're gonna develop that further. And we're gonna find an arc tangent to two lines at any angle. Okay, so this takes care of a right angle, but what if it's not a right angle? What if that angle's open more or it's sharper? This technique will allow us to develop that. So our given is going to be two lines, any angle, and arc of a known radius. So we have to start out by drawing two lines at any angle, and I need you to pay attention to how I do this, all right? I'm going to draw a line on an angle, on an uphill angle, and then I'm going to draw another line on a downhill angle, but not too close to this short side here. I want to come down a bit, give it some breathing room, all right? And then I'm going to draw a line out on an angle. So the key thing here is not too close on this end. So go ahead and draw those two lines at approximately what I have. And we're going to then grab our compass and we're going to make this one smaller, right? So as a guide, open your compass up to about half of this opening. That's why I didn't want that too small, because half a small was super small. So I'm going to close my compass down, and I'm going to have it about halfway across this small end here. And what I'm going to do now is I'm going to strike a semicircle arc near the ends of these lines. But I don't want the arc to go past the line, so I'll do this one first. So you can see I'm going to come in from the end of that line a little bit and draw a semicircle arc. And I'm going to do the same thing on the other end. So where that exactly is not critical. Just make sure it's in from the end of the line. You don't want it to go out past it. And you know what? If it did, it wouldn't be the worst thing in the world. I'm going to label that as arc 1 and 2. Now I'm going to do the same thing on the other line. I'm going to draw 2 semicircle arcs that are within the line. And you can see the small arcs are a little harder to draw. You've got to be a little more careful. And that's where the correct point adjustment becomes more critical. Small arcs. All right, so there's 2 more arcs, and I'll call them 3 and 4. So this one has more setup. There's more construction to get to the end result here. What we're going to strive for is on this small end having an arc that blends perfectly, comes around and blends back in or becomes tangent with that one. So we're going to be looking for a center point somewhere in the middle of this area here. So now the next step is I'm going to do this in a different color so it stands out. I'm going to draw a line that is tangent from arcs 3 and 4. So I want to line my straight edge up to just skim the outer edges of these 2 arcs. So I'm going to draw out that way. Now, I can't erase this red pen, and in reality I wouldn't do that. I would use a very light construction line, but it stands out better on the video. And now I'm going to do the same thing with arcs 1 and 2. So I'm going to line that up, and I'm going to draw another line tangent to both these arcs, and I need that line to cross through the first red line. Okay? And where those 2 cross, this is the point that I'm looking for right here. So I did all this construction to find that point. And now that I have found that point, I can take my compass and I hope you didn't readjust it. And if you think you did, you can just set it back on one of these arcs and make sure that it is the same size. Now I'm going to put my compass point right on the intersection of those 2. And I should be able to draw an arc that is tangent from one side to the other. Okay, and I would go back and I would draw with my thicker lines and then add my thicker line to the arc so that it matches up with all that. And when all is said and done, you have a nice arc tangent to 2 lines at any angle. Okay, so that one's about as complex as we're going to get tonight. And that is a good one, because number 2 is popular, and this is a takeoff. This is makes tangent curves, so straight lines, covers all bases. All right, finally, we have number 4 here is dividing a line into equal parts. So that's what the problem we have to solve. So our given on that is line AB and then number of parts to divide. Now that's something we will need to know. So let's just say I'm going to use our end number 7. So let's draw a line AB. Now keep this line low, towards the bottom of the page because we're going to need space above it. And again, it doesn't matter the orientation or the length. So I'm going to come down low and I'm just going to say, all right, this is line AB. So I need to divide that line equally in 7 parts. And I'm going to be able to do that without ever taking a measurement. Okay? So the first thing we're going to do is we're going to put our pencil on A, on the end of A, and I'm going to take a straight edge and just go off on any angle, right? Let's say I'll go up, and I'll draw a line at any angle, any length, any angle. And I think for the sake of this demonstration, I'm going to make this a little bit longer because I'm a little bit limited with space down here, so that'll make it a little easier. But it can be any length, any angle. Now, we're going to use a tool we haven't used yet, the dividers. So take out your dividers. And is there anything we need to worry about this? The only thing would be to make sure that the pins are out the same amount, and about the same amount. I mean, if one is ever so slightly longer or shorter than the other, that's not going to make a big deal. But most importantly, tighten it till it hurts. Make sure that both of these wheels are as tight as you can get them. Otherwise, it's going to slip up inside there and mess you up. All right, so instead of striking arcs with our compass and leaving a trail of lines here, what we're going to do is stab little holes in the paper. Now, I need to adjust my compass to no specific amount other than I need to lay out 7 of these, one after another on this line. So if I opened it up to this, right, and I would step off this amount, I'm going to quickly run out of line before I get to 7. So I'm going to bring that down smaller. And I'm going to stab into the point A on that line, and then I'm going to stab into the angled line. Okay, so put a nice healthy hole in the paper, and I put it ever so slightly on the side of the line so that I can see it a little easier. And I don't know that you can see it, but I'll go down in there close. It's probably really tough to see, but there's the little hole in the paper right there. Okay, so now without readjusting my dividers, I'm going to put the pin in that new hole I made and then step off another hole past that. And I'm going to do that 7 times right on the edge of that line where it's visible. So I got 1, 2, 3, 4, 5, 6. Got one more to go here, and 7. This guy right within the line and mark the space. Just going to put that just on the edges. There we go. So I now have 7 little holes in my paper that are equally spaced from whatever measurement I decided to open the compass up with. Now I need 2 straight edges, so use both of your triangles. I'm going to use this triangle because I don't have a lot of room down here and I can pivot this here. And I'm going to set this triangle on top of it. What's important here is that I have a right angle between these 2 triangles. So that's critical. So it doesn't matter what side you put it on, just as long as you can push this on it, and then you're going to be holding this triangle down and sliding this across there. So you're going to have to really press down to keep this still. So what I have to do is, and here's my 7th little mark right there. I'll put a little arrow so it's a little more visible. I need to line up B. I need to pivot this to find B with that 7th little increment out here. So once I find that angle by setting my straight edge against, my triangle against this triangle, I hold this one still, and I draw a line connecting it. And now with this one pressed down and held still, I slide this across to the next one. If you think you messed up, just go back and make sure that this one lines up. But I'm going to slide it over to here, and I'm going to draw another line. And those seems to be in the shadow here, so it's hard to see. And then I'm drawing that down. And I repeat that. Slide this down, draw. Always maintaining this angle. I do that 7 times. And I will now have divided this line equally into 7 parts. And I never had to take a measure. All right, I hope that was understandable. You'll have the benefit of pausing the tape, or, the recording and rewinding if need be. Okay, so there are 4 geometric constructions, getting us a little better with our equipment. And that takes care of topic number 1. And I'm going to remove the paper, and we're going to advance to topic number 2, which is scaling. Now with scaling, I'm going to need you to grab hold of this paper. That's on Moodle. And your yellow scale. And the one that says 16. Now scaling, I could talk till I'm blue in the face and we'll have long fallen asleep. But it's really a performance skill. And I'm going to give us tips and tricks and show us how, but beyond that, you have to just go at it, and you have to grind away and learn by doing. And it's really, pay attention to these tips and tricks. Now, I'm going from the assumption that we don't know how to read a scale, even though in the first couple of classes we've been kind of managing with inches and eighth inches and things like that, but you really need to understand the incremental breakdown. This is a good handout which will get you used to that. Now, this has a temporary flaw in it, and I say temporary because there's more on this than we really need to have to deal with at the moment. But it's not something I can later on add in there, so it's there until we learn how to understand it. And that can be a problem. And what I'm specifically referring to is the way these little graduations, these lines, these increments are laid out on here. There's more than there needs to be. And these really thin, short ones really don't need to be there for now. All right? They are not on this scale. And that can potentially cause you a problem until you realize that. So you really need to ignore these tiny ones. So where this can be dangerous is if I said to you, I want you to count and find me 3/16, right? Because on this scale, this scale that says 16, this is a full inch, a real world inch. If the weatherman said we're going to get an inch of rain, that's how much we would get, between 0 and 1. This is just divided into 16 equal parts over that 1 inch. And you'll notice that these little lines or graduations are at different lengths. And the super tiniest ones are at a 16th. So anytime you land on one of those really small ones, it's going to be something to the 16th. So let's say we'll take the second really tiny one away from 0, right here where my pen is. Hopefully you can see that. If you were to count, it'd be 1/16, 2/16, 3/16. If I were to ask you to do that on this paper, you can potentially do this wrong. If you were to count each and every one of these as 1, 2, 3, 16, that would be wrong because these are not 16ths. These are 30-seconds. So you have to ignore the tiniest of these increments. They're not even labeled, right? So don't use them until we're ready for them. So if I were to say 3/16, that is labeled here. So it's 1, 2, 3, right? You skip the short one. So all of the increments are properly labeled across this top row of numbers here. We have a second, third, and fourth row of numbers just to help you get used to this. So if I were to tell you to count 16ths and you said 1, 2, 3, 4, 5, 6 16ths, right? Try that again. 1, 2, 3, 4, 5, 6 16ths. That is labeled right here. But you should never ever say that out loud. As a matter of fact, any of these on the second, third, or fourth tier are just to help you locate, but you should never write or you should never verbally describe them. That will discredit you to somebody listening to you and saying, what do you mean 6 16ths? That's supposed to be 3/8, right? That says you're saying in so many words, I don't know what I'm doing by calling it 6 16ths. So in your inner voice in your head, absolutely, whatever it takes to get you there. But outwardly, never say anything or write down as a measurement from the second, third, or fourth tier. Always the lowest common denominator if you want to think of it as a math issue, right? If you were to say, what's the lowest common denominator of 6 16ths, it's 3/8. So that's what you want to outwardly describe, verbally or writing. Okay, so we just have to get used to, recognizing an increment and its actual value. And the way you'll do that is you'll start basic from big and you'll refine small. So that can help with these increments. The larger ones, the largest ones are 0, 1, 2, 3. The next shortest ones are at the halfway point, or ½ inch, right? So that's a ½ inch. There'll be another one at 1.5, 2.5, all the way through. Then you get the next smaller one is at 1/4 inch increments, right? So 1/4. You could say 2/4, right? 2/4 down here, but that's still a ½ inch, right? So 1, 2, 3/4. And then working your way down. Then you have the 1/8 inch one. So you've got 1, 2, 3, 4, 5, 6, 7, 8. 8/8 is 1. And then 16ths, right? So you've got all of these 16ths going across. 1, 3, 5, 7, 9, 11, 13, and 15, 16. Now, if I were to tell you to find the 11/16, sure, you could go here and say 1, 2, 3, 4, on your way up. Or, you're starting to get it when you say, well, I can find 8/16 or a ½ inch really fast and then just go from there, 9, 10, 11, right? So when you start getting to ones that you can find easily to get to the one that you really need, that's when you're step up on the experience ladder. So if I were to say, find me 13/16, you'd say, okay, over here is 16/16, 15, 14, 13, right? So I got to that a whole lot faster than saying 1, 2, 3, right, and working that way. Or you'll say, okay, 3/4 inches is also 12/16, and just go one more. Okay, so you want to try to get to that point. And then before you know it, you're just going to know it. All right, it's just going to be second nature. But you've got to grind your way through to get to that point. It's not going to happen by wishing it'll happen. Okay, so now where do we go from there? All right. Now, on the 16th scale, doesn't matter where you are along here. If I'm somewhere 5 and a few increments here, I have to find where that is on the chart to be able to know what that is. All right, that's at the beginning. But that, this layout doesn't change no matter where you're at along that scale. Now, I do want to acknowledge another kind of discrepancy. On the scale, we're at 0 on the left and counting upwards to the right. Whereas on this handout, 0's on the right and we're counting up on the left. Right? Now, why is that and why do we have the 30 seconds? Okay? The answer to that comes when we start looking at the other scales. Okay? If I'm looking at the 16th and I roll this towards me, I see a whole other set of scales. There's 4 more. There's the one that says 1/8, upside down to that 1/2, and then on the other end 1/4 and 1. This whole surface of scales is the architectural scale. This does not represent inches. This represents feet. We're not even ready to go there yet. So let's ignore the eighth, half, quarter, and 1. And let's go back to the 16th and then roll it away from you until you see the ones that say the word size, 3/4 size, 1/4 size, and on the opposite end, 3/8 and half size. That is broken down to an inch. Now, take a look at the 3/4 size. What you see in this little area here is how this handout is laid out. Why? Because we're going to use this scale a lot. What does this actually mean, 3/4 size? Well, that means it's being reduced to 3/4, or another way that you might recognize, 75% of actual size. Okay? I go to the opposite end to see half size. That's 50% actual size. Think about it. If you go to a copier machine and you put your original in and then you type in on the controller 50% and then hit copy, you're going to get exactly what the original looks like, but half the size. Okay? That's what this scale is going to do. Only it seems that the 3/4 size works best for us. We're only shrinking the drawing down a little bit, 75% actual size. But we don't have to change our method. We still measure and draw using this scale. It's just going to come out a little bit smaller. I don't have to take my numbers and multiply them by 0.75 or do any math. I just take the measurements and I lay them out to what the scale shows me, and they automatically come out 75% actual size. So I have to show you how to do that now. And that's, if you want to get a piece of scrap paper, that's what we're going to do next. Okay, so I am going to draw a line of a random length. Okay, so I just drew this line, and now I want to show you how you would measure what the length of that line is at 3/4 scale using this system. So any of these scales that have that little compressed area on the outer end, this technique is what you would do. So the first thing you do is you lay the 0 down on the left side of that line. And I now look to the right and I see it's more than 3, less than 4. Now if that's a little tough to see, I'm going to bring this down in a little bit closer. Okay? So it's 3, more than 3, less than 4, and I see 22. What is that 22? Well, that 22 and this 20 and this 18 is coming from the scale on the other end, which is the 3/8 scale. We don't have to worry about that. But that 22 is also, could be seen as 3.5 inches. And the 20 could be 4.5 and so forth. So looking at this line, I know I'm between 3 and 3.5. So that helps me understand where it's going to be. So now what I do is I slide the scale down so that it's 3, and then I look over here to see what the larger part of 3 is, right? And this is where you really have to look carefully. And if I count increments, it's 1, 2, 3, 4 16ths, right? 4 of those notches. But I know I can't say that 4 16ths. 4 16ths is a quarter. Right, so I counted 4 of those increments. 1, 2, 3, 4. Okay, let's look at that again. Make sure that's lined up here. Okay, so it's 1, 2, 3, 4. So that's 3.25 inches in length at 3/4 size. So we would have to know that this is 3/4 inches equals 1 inch. That's how we would formally write the scale. So what does that mean to us? When we have our drawings, we have in the title block a category that says scale. The assignment that I gave you last week that's due this week, the scale of that, I told you to just write the word full. Full means 1-to-1 or actual size. Now we're going to start getting more specific. The scale for this line on that drawing you would write as 3/4 inch equals an inch. Another way of saying that, for every 3/4 inches on my line work, it represents 1 inch in the real world. Now, I would say that this line measures, right, we measured it, it's 3 1/4 inches in length. Okay, let's try this again. I'm going to draw a line of another length. This is also 3/4 inch scale, so I know I have to look at the 3/4 size. And I'm going to line up the 0 on the left end. Okay, take you down a little bit closer here. So I'm lining up the 0 on the left end. And I'm looking over to the right end, and it's 2, and it's past the halfway, so I'm pushing almost 3 inches here. But I still slide my scale over so that the 2 lines up. And then I look over here, and I see it's right on this mark here, which I know is something big. So what is that? Well, that's something eighth, right? So if I count eighths, 1, 2, 3, 4, 5, 6, 7 eighths. If I want to take the long way over, I would go to the next shorter increments and count them. And I'm going to wind up with 14 sixteenths. That's a painful way to go there. Another way of looking at it is go the full and subtract 2. Remember, we're ignoring the tiniest ones. So 2 increments in less than a full inch. So that would be on the handout here, 1, 2. So there's your 7/8. So this is 2 7/8 in length. So that is what we have to get used to immediately. I mean, you're going to have a homework assignment that you're going to have to draw at 3/4 size, and you simply lay out all your measurements on this scale. And anything that's a fraction of an inch, you've got to find over on this graduated area here. And that's a skill unto itself, and that skill can apply to any scale on any ruler, so to speak. Okay, so I know I've gone over 2 examples, and that hardly makes us experts, but like I said, you're going to have to take that knowledge and you're going to have to grind a way to figure that out. All right, I'm going to show you one more thing here on the other scale, the engineering scale. Okay, find your engineering scale and locate the 10 on the outer edge, 10. Now that 10 is the equivalent of full scale or the 16ths on the other scale, whereas 0 to 1 is a full inch. So if we got an inch of rain on this scale we'd measure, that's what it would be. The obvious difference is that this is divided into 10 equal parts, whereas on the 16th, it's 16 equal parts. But an inch is still an inch. In other words, if I line these up, you'll see that the inch is exactly the same. And it's just 16 divisions, 10 divisions per inch. Now, this scale does have a deficiency when you're dealing with fractions. So if I were to tell you to find a measurement, for example, let's say 2 5/8. Now that's not a difficult number to find, 5/8, but we don't have fractions here, so we would have to break this down and find out the decimal equivalency of that. And the way you would do that, there's 2 ways. If you had a calculator, you'd say 5 divided by 8, and that would be 2.625. So 5/8 is 0.625. So if I needed to find 2 5/8 on here, I could easily find 2, and then the 0.6, I simply count 6 increments over, so I'm 1 notch past the halfway. But then the 2/5 part is actually 0.025. That means I'm a quarter of the way to the next increment. And I've got to look and say, oh, it's about here. That's a pretty big distance between increments. And any time I find myself saying, oh, it's about here, I am not using the right tool. You shouldn't be ever doing that. So if you're 2 to 3 decimal places, this is just not the right tool to use. So where this excels, as the word engineer comes into play, is that civil engineers that measure land and larger distances would use this as not 1 inch, but every tick mark would be a foot, 1 foot. So this would actually represent 10 feet, 20 feet, 30 feet. So another way of saying this on that 10 scale, right, is, I'll just write this big so you can see it. On the 10 scale, that actually means 1 inch equals 10 feet, 0 inches. That's the way it would be written. So the 10 really means 1 foot equals 10 feet, 0 inches. So if I were to flip this around, let's say opposite, and I see 20, the 20 would mean 1 inch equals 20 feet, 0 inches. And I think I messed up on the first one there. 1 inch is 10 feet, and this is 1 inch equals 20 feet. So the 1 inch equals 10 feet. The 20, 1 inch equals 20 feet. And so forth. The 30, 1 inch equals 30 feet. Now, I want to quickly show you a practical application for this in the civil engineer world. There are common drawings that civil engineers use called a site plan. Okay? What is a site plan? This is a piece of property. Somebody owns this piece of property. It's a little tough to see, but this box here is the outline of the house. This is the front porch with a walkway. The street is down here. You have a wooden deck out the back, steps, and so forth. Now, I'm going to take you a little closer. Looking at the information on the drawing, this looks like 50.0. I don't know if you can see the decimal place, but that actually means 50 feet, 0 inches. If we look at the side of the house, this is 100 feet. So this property outline is 50 feet wide by 100 feet deep. Now, I could measure that, but I can only measure that if I know what scale to use. So it's very important that you put the scale in the title block. Now, this paper is kind of getting, seen better days here, but if I go in real close, I can see scale, 1 inch equals 20 feet. So now I know to get my scale and find 20. And if I put that scale down and I measure the width of this property, remember, each one of these is a foot, so that's 10, 20, 30, 40, 50 feet. Look, that's right on the money. That measures exactly 50 feet. So I can actually measure this drawing. It says that the front of the house is 28 feet from the street. So if I line this up, I should have 28. And there it is, right? There's 28 right there. It's a tiny, super tiny bit off, but there's another reason for that. This piece of paper is actually a fax. So when you fax something, it might lose a little bit of its accuracy. It certainly did, but that's pretty darn close anyway. Now, let me show you one more variation of this. Here's another site plan. It's cleaner. Okay? So we've got the property outline around here. We've got the house. It's a little easier to see the house. This particular drawing says scale 1 inch equals 30 feet. Okay, so now I have to find the 30. And then the width of this property here says 75 feet, which would be from this line here to this line here. So let's check that. So it should be like 7.5 here. Okay? So here's 7, and then that tick there is the halfway point. So once again, that's right on the money. I think I moved my scale. Yeah. Whoop. Okay, so 7.5 right there. And then this is also 125 feet deep, which should be 12.5. Okay, so here's 12, which is 120, 1, 2, 3, 4, 5. So 125 feet deep. You can see it. Okay, so that's how you would use this type of scale on an engineering type drawing. This is a civil engineering drawing. So I have an informal assignment for you. You may be living in the house with your parents who own the house, or you may be the homeowner, or anything in between. But if you can get your hands on this site plan and take a look in the title block and look for the scale, all right. So if you're a younger age and you're living with your parents or somebody who owns the house, ask them, say, hey, can I see the site plan for this house? And they may say, what? What is that? And you hope you don't get that answer. But hopefully they'll say, yes, I have it in with my mortgage papers. Because when you buy or sell a house, that's usually part of the big picture. You have to have a survey done and get your site plan updated or created. And then that's all part of the selling or buying process. So those papers should be accessible. To get a survey done can be anywhere, $400 on the low end to, a couple of thousand, depending on the complexity of your property. Okay, so those are not drawings or papers that somebody wants to lose. All right, so see if you can do that. All right, the more we dive in and take measurements and read drawings, the better we're going to be in the end here. Okay, so that takes care of scaling, right? And you have your work cut out to overcome this 3/4 size and translate, the measurement on here to the line. All right, I'm going to stop the recording and then I'll restart it and continue on the next topic. I just don't want these files to be too big. They take a long time to upload and download. All right, so we'll see you in the next part.